Hello guys and welcome. I hope that you're having a great day or good morning or good evening. Merry Christmas, by the way. It is December 25th 2019, just before the new year of 2020. In this video guys, today I'm going to show you CSGO running with two Titan RTX SLI through NVlink bridge and Core i9 9900K overclock at 5.3 gigahertz with 32 gigabyte of system RAM. Let's go ahead and get going, guys. I will explain to you during this video why you don't want to play CSGO in 4K resolution with two Titan RTXs, 24 gigabyte of VRAM each. So I'm going to go ahead and show you the specs. Everything will be maxed out, guys, including the anti-aliasing, as you can see. Every possible visual set to maximum. Anti-aliasing will be 8 times MSAA. Okay, and we're going to go ahead and play the demo that I'm always playing. And it's going to be great. Grand final match 103, as you can see, guys, on train. That was recorded in July 10 2016. It was the grand final between the SK Gaming and Team Liquid. Let's go ahead and get going, guys. Oh, I forgot to remove the HUD, so we're going to start the game and I'm going to remove the HUD. Yeah, let's go ahead and do that because I forgot to remove the HUD. Let's go ahead and start the game and remove the HUD. I think it's going to be nice. I'm going to use the command CL underscore draw HUD space 0. So it's going to remove all the HUD in the game, and we're just going to look at the game and we're going to look at the FPS. Open the console, CL underscore draw HUD space 0, enter. Here we go. We remove the HUD. Let me real quick go ahead and reboot the game. Okay, here we go. Guys, I'm going to attach this demo file in the video description. Go ahead and download it so you can play it and test it on your PCs to see the performance. So as you can see, guys, at the left top we got the system information updated every second about our PC hardware, and I call it tougher. Self-explanatory. T stands for the temperature, U stands for the usage, F stands for the frequencies, FR stands for the fan rotation. So temperature, pretty much in Celsius, as you can see, I have the CPU temperature and I have the GPU's temperature. Two GPUs because two RTX 2080 Ti with, two Titan RTXs in SLI, so two video cards. Then I have percentage. Percentage will be our CPU usage. It will be GPU usage. I also put all the 6 cores. I'm using today i9 9900K overclock at 5.3 gigahertz, but to keep it stable and cool, I disabled 2 cores and I disabled the hyper threading technology to be able to keep it at 5.3 gigahertz per core per thread. Keep that in mind. So 6 cores, 6 threads, and it doesn't matter if you're using 6 core or 8 cores in the CSGO or 24 cores, the performance will be the same after 6 cores. Okay, so in percentage, the usage of the CPU, we want to keep below 92%. If you are reaching above 92% on your CPU, you want to go ahead and add 2 more extra cores. Okay, on the GPU, we want to keep our percentage rate on GPU 1 and GPU 2 97% and above. So we want to have on GPU opposite of that, 97% and above, like 100%, to make sure that we're going to utilize our GPU, because full GPU utilization in the games will give us the maximum FPS. So we can utilize the 46 CUDA cores that I'm having today, guys, on each Titan RTX Turing GPU architecture TU102 GPU. So Then I have the utilization of the VRAM, which is 4,495 megabytes right now. Then I have the utilization of my system RAM, which is 8,838 megabytes. Then I have the frequencies for the CPU, which is pretty much clocked at 5.3 gigahertz with 53 multiplier per each core for external frequency, and 50 multiplier for the AVX instruction. For the AVX instruction, frequency will be 5,000 megahertz or 5 gigahertz. So external frequency 5.3 gigahertz or 5300 megahertz, and AVX frequency is 5,000 megahertz or 5 gigahertz. But as you can see, jumping 5300 megahertz and 5000 megahertz, and this is what the 9th generation Core i does, guys. CPU does. They pretty much using the external frequency, and when they're not, they see that the CPU can breathe, doesn't have that much instruction to compute, it's go ahead and will switch to AVX instructions. I'm not sure why it's doing that, but there is no way for me to switch and to change that in the BIOS of ASUS Maximus 11 Hero motherboard. And I believe that you cannot change this on any i9 generation Intel CPUs. Okay, then I have the frequency for the Titan RTXs, which is 1890 megahertz right now per each GPU, and it's synchronized. So frequency on the GPUs, VRAM frequencies are synchronized, and fan rotation synchronized at 100%, as you can see. So fan rotation only available on the Titans, which is 100%, because on the CPU I'm using today the Corsair all-in-one water cooler, which is H150i Pro, 360mm radiator with the 3 120mm fans. My CPU is also on a liquid metal thermal compound paste by Grizzly, Thermal Grizzly, which one of the best thermal compounds out there if you want to decrease your temperature on your CPU to the minimum as possible in a home safe environment. That's it, guys. As you can see right now, utilization of the CPU is below 50%, so that means that we pretty much kind of utilizing only 3 cores fully. So 3 cores kind of can be empty. So if I would be playing right now on a quad core, I'm going to be below 90% on my CPU usage on a quad core with the 4 threads, not the 8 threads. Okay, with the 8 threads, it's going to be even lower than I'm having right now under my CPU usage. So it's going to be about 30%. Right now I'm having like 41, 42, sometimes switching to 33. Then my GPU utilizations, guys, as you can see, below 80% per each GPU utilization, and this is very bad SLI scalability. It is faster than Titan RTX because it's below 80%, so it is faster than Titan RTX single video card while I'm running those 2 Titan RTXs and SLI, but it's not performing as it should be. So the performance over single RTX Titan RTX will be 1.4 times maximum, and it's pretty much waste of money. So this is pretty much why you don't want to run Counter-Strike or Counter-Strike Global Offense or CSGO in 4K resolution on 2 Titan RTXs, guys, and SLI. You better probably stick with single Titan RTXs and not even Titan RTXs at 4K resolution, because everything will be waste. You're not even going to utilize the single Titan RTX, guys, at 97-99%. And I'm going to record this video, and this video will be available over iPlay4k.com or over the iPlay16k.com YouTube channel, because I was the first YouTuber that showed you Counter-Strike Go or CSGO in 16K resolution on 2 RTX 2080 Ti and SLI video cards back in July of 2019. Go ahead and check it out, that video. It's going to be amazing. As again, just visit the iPlay4k.com YouTube channel or iPlay16k.com YouTube channel and you will see it. As you can see, FPS, guys, yeah, FPS staying above 250 FPS average pretty much all the time. Today I'm recording this video with the NVIDIA ShadowPlay software that is recording on the same computer, so it's pretty much wasting 3 FPS while it's recording it. So go ahead and add 3 FPS to the FPS counter if you're not recording, but pretty much FPS staying pretty high. I would say FPS staying around 290 FPS average, as you can see, but sometimes it's getting like to 225 as I saw as minimum, but still above 200 FPS average. Okay, milliseconds delay, guys, is below 5 milliseconds, as you can see. That means that the gameplay is very comfortable. When your milliseconds latency delay between rendering each frame, as you can see it's in milliseconds, is below 10 milliseconds, it means that your gameplay is very comfortable. But when it's below 5 milliseconds, it's amazing, okay, in terms of comfort. What else? Pretty much that's it, guys. As you can see, most of the cases somehow it's my CPU frequency is staying at 5000 megahertz, even if the external frequency is 5300 megahertz, because the CPU doesn't believe it's stressed enough, and it's kind of chilling at 5000 megahertz instead of 5300 megahertz. But sometimes, as you just saw it, it's switching to 5300 megahertz. So the CPU using the DirectX API, which is 9C in this source game engine in CSGO, thinking that it's not, you know, it's not stressful enough for the CPU. So even you don't want to have a very fast CPU. But as again, I'm using this system, guys, because I'm also going to record 16K resolution on 2 Titan RTXs in SLI for you, and I'm also going to record 8K resolution on 2 Titan RTXs for you. So I need as much as fast as possible that we can get in 2019 in terms of PC. I also, guys, today using the cheapest possible Corsair DDR4 system RAM as possible. It's 32 gigabytes, but it's 2133 megahertz CL13. And if you will ask me why I'm not using the top of the line like 5000 megahertz DDR4, because I believe it's waste of the money, especially when you're playing 4K resolution and above. DDR4 at high frequency will give you some performance like about 6-7 FPS at 1080p, even sometimes even 10 FPS at 1080p, and at 1440p it will give you like 6 FPS boost if you're going to use top of the line DDR4. But as again, I'm not playing 1080p or 1440p, so I don't see a reason why I should do that. Okay, I like to play the Ultra HD resolutions, 4K resolution and above. I love to play 8K resolution, and in CSGO 16K resolution is playable with 2 Titan RTXs like no problem. Go ahead. In the end of this video, guys, I'm going to include CSGO on 2 RTX 2080 Ti in 16K resolution, as well as CSGO on 2 Titan RTXs in 16K resolution, as well as both of them in 8K resolution. You don't want to miss that. It's going to be amazing. 16K resolution will show 16K resolution and 8K resolution, but I'm going to record individually 4K, 8K resolution and 16K resolution, guys. Okay, so pretty much you saw the difference. And if I'm going to disable the anti-aliasing, let me go ahead and disable the anti-aliasing real quick just to show you the difference. The FPS will go even lower than you just saw it. Okay, so it's no reason for you to run it without the anti-aliasing if you have single RTX 2080 Ti or even 2 RTX 20 Titan RTXs or RTX 2080 Ti, because pretty much those GPUs almost performing the same. Titan RTX has 4600 CUDA cores, which is a little bit more than in terms of when we're comparing with RTX 2080 Ti. But RTX 2080 Ti can be overclocked above 2000 megahertz, and Titan RTX cannot be overclocked above 2000 megahertz on the air. And today I'm running both of them on the air. There is like a little room between of them to breathe, and 2000 megahertz and above 2000 megahertz is unstable through the MSI afterburner on the Titan RTXs. Keep that in mind. So as you can see, same FPS, and yeah, there is no difference. Okay, milliseconds delay maybe below 0.5 milliseconds delay, but still it doesn't matter. Right now though, we're utilizing more of our CPU, as you can see when I disable the anti-aliasing. I just saw above 50%, as you can see 52% right now, 53%, and we're utilizing less GPU. And you don't want to avoid this type of scenarios. When you're playing PC games, you want to stress your GPU as much as possible, like I told you, 97% - 100%. Okay guys, that's pretty much it, guys. Right now I'm putting for you the videos to watch. Like I told you, RTX 2080 Ti and SLI 16K resolution, single RTX 2080 Ti and SLI 16K resolution. Both of those videos will feature 16K resolution and 8K resolution, 10K resolution and 12K resolution, as well as I'm going to put for you a single Titan RTX and 16K resolution, and two Titan RTX 16K resolution. Go ahead and check it out. If you don't see this right now on the screen, go ahead and check the video description. Okay, before let me quit the game. Before I will let you go, let me real quick, guys, to show you what kind of system I was running today, just as a verification for those naysayers. As you can see, 5.3 gigahertz, my CPU was clocked, but it's switching because the 9th generation Intel i CPUs, and it's kind of weird the way they're managing the frequencies throughout the load. Motherboard was ASUS ROG Maximus 11 here Wi-Fi. I told you about DDR4, the cheapest possible, 2133 megahertz CL13. As you can see, 1066, you got a megahertz, you got to multiply it by 2, 32 gigabytes. Is again my graphic cards, beautiful Samsung GDDR6, very overclockable VRAM, but today it was running completely stock. As you can see, the single thread performance 620 out of this 5.3 gigahertz, only 6 core 6 threads, absolutely amazing. This is what you want to have, the maximum possible frequencies and the maximum possible performance per thread. And the multi-threaded performance 3672 comparing to the i9 with the 8 cores 16 threads, because I disabled my 2 cores and disabled the hyper-threading technology. It's faster than mine throughout the multi-threaded performance, okay, but it's much slower by about 50 points throughout the single threaded performance, and we want to every single threaded performance as fast as possible. Okay, so pretty sure at this settings, if I would have 8 core 16 threads, I would probably land it around 6500 under the multi-threaded performance. Okay, so use the same benchmark CPU Z if you want to. This is my version right here, 1.88.064 bit, and the benchmark version 1701.64 if you want to match compare my performance. This is my GPU Z information, as you can see, beautiful. By the way, during GPU architecture, Titan RTX has 6 megabyte of level 2 cache versus the Pascal GPU architecture Titan XP. That one only had 2 megabytes of level 2 cache. So pretty much we have 3 times more level 2 cache, and this is why the Turing GPU architecture is allow us to run 16K resolution, guys, and you don't want to miss it out in CSGO over the iPlay4K.com YouTube channel or over the iPlay16K.com YouTube channel. Alright, guys, self-explanatory. Let me show you a little bit. This is the CUDA cores and this is the Tensor cores, 24 gigabyte per each video card VRAM, and the 6 megabyte level second cache. Okay, guys, as again, thank you so much for watching, and right now I'm putting some great videos for you to check out. Go ahead and check it out, and guys, I will see you in the next videos. All right, iPlay4K.com. Till the next time, have a great day, Merry Christmas and Happy New Year, Happy 2020 New Year, guys.